Hello and welcome to Algebra 2 Lesson 17. In this video, we're going to learn about the slope of a line. So for the majority of you, you've taken Algebra 1 already, and you're already very comfortable with the concept of finding the slope of a line. For others, you skipped over Algebra 1 and just kind of jumped into Algebra 2, or you might just be fumbling around trying to find help with your homework on slope. I can tell you, if you fall into that category, you can definitely pick up slope from just watching this video. It's a very, very easy concept. So the slope of a line is nothing more than a measure of its steepness. You can think about some real-world examples of this. You can think about the slope, or the pitch, as it's called, of a roof. We all know that different roofs have different steepnesses, and so they have different slopes. You can also think about the slope of the roads that you drive on. This is often called a grade. So different roads that you drive on, depending on where they are going to have different steepnesses, different slopes, or different grades. So slope is nothing more than the ratio of vertical change, which is known as the rise, to horizontal change, which is known as the run. So we're going to hear this for the rest of our life. Slope is the rise over the run. I want you to write that on a flashcard and memorize that. You're going to hear it over and over and over again. So you've got to kind of know that. All right, so actually calculating slope is very, very easy. We're given this formula for when we know 2 points on the line. So to calculate the slope of a line when 2 points are known, we're given this formula, again, that's known as the slope formula. So M stands for slope. That's another thing you want to write down because a lot of times you're expected to notate your slope with M. So M stands for slope. And we have that it's equal to. So for the slope formula, we have these two inputs for y and these two inputs for x. So let me explain real quick. We have y and then we have a little 2, and then y and then a little 1. So it's a subscript in each case. So we say y sub 2 minus y sub 1. This is just a way to notate the different y's that we have. We have two ordered pairs that we're working with. So x comma y and then x comma y. So I need to know which x I'm referring to and which y I'm referring to. So the way we notate is we say, okay, this is x sub 1 and this is x sub 2. This is y sub 1. This is y sub 2. And you don't mix and match. You don't say this is x sub 1, y sub 2, and this is x sub 2, y sub 1, for example. You want to keep those notations consistent, right? So if this is x sub 1, this is y sub 1. If this is x sub 2, this is y sub 2, okay? That's going to help you with your formula. Now, all I do once I've notated things is I just plug into the formula, okay? It's very, very simple. So y sub 2 minus y sub 1 is the change in y values, or the rise. And then x sub 2 minus x sub 1 is the change in horizontal values, or the run. So again, we see this rise over run. Now, one little note before we kind of move on, we have that x sub 2 minus x sub 1 cannot be 0. And that's because if this is 0 here, we'd be dividing by 0, and that's not allowed. All right, so let's go ahead and take a look at 3x minus 2y equals negative 6. So normally I would just give you 2 points and say calculate the slope, but let's make it a little bit more interesting. So we have 3x minus 2y equals negative 6. Just generate any 2 points that you want and plug them into the formula I just gave you. I'm going to go ahead and use the x-intercept and the y-intercept because those are pretty easy to get. So for the x-intercept, I plug in a 0 for y. So for my table of values, if I plug in a 0 for y, what would I get for x? I'd have 3x minus 2 times 0 equals negative 6. This would cancel and be 0. I'd basically have 3x equals negative 6. Divide both sides by 3, and then get x equals negative 2. So x is negative 2 when y is 0. Now for the y-intercept, I know that I want to plug in a 0 for x. So if I plug in a 0 here, I would have 3 times 0 minus 2y equals negative 6. So that would cancel. I'd have negative 2y equals negative 6. Divide both sides by negative 2. And I'll have y equals 3. So x is going to be equal to 0 when y is 3. So now I have 2 points. And if I have 2 points, I have enough to calculate the slope. So I know you probably don't remember the slope formula from the other page. So let me scroll back. And I want you just to copy it down. We have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So again, that slope formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now I have 2 points here. I have negative 2, comma 0, and I have 0, comma 3. So the first question everybody asks, and you know I talked about this a lot when I taught Algebra 1, what point do I label as x sub 1, y sub 1? What point do I label as x sub 2, y sub 2? This is going to come up in your head, and the answer to that is it doesn't matter. Write that down now, because you're going to ask that question again if you haven't asked it already. If I start out and say this is x sub 1, and this is y sub 1, and this is x sub 2, and this is y sub 2, I would get the same answer as if I changed this, and I said this is x sub 2, this is y sub 2, this is x sub 1, this is y sub 1. Okay? What I want to do is just make sure I'm consistent with my notation. So in other words, if this is x sub 2, this is y sub 2. Okay, I have a 2 in each case. If this is x sub 1, this is y sub 1. I have a 1 in each case. So now that we've got that covered, we just plug into the slope formula. Y sub 2 is 0, so I'm just going to erase this and put a 0. Y sub 1 is 3. Erase this and put a 3. X sub 2 is negative 2, so erase this and put negative 2. And then x sub 1 is 0, so erase this and put a 0. So 0 minus 3 is negative 3. Negative 2 minus 0 is negative 2. Negative 3 over negative 2 is 3 halves. So what does this mean, m equals 3 halves? Well, a slope of 3 halves means that, again, I go back to the definition. I rise 3 units for every 2 units that I run. So graphically, if I started out at a point on the line and I went up 3 units and I go to the right 2 units, I'm going to go back to that line. So let me graph this line and we're going to show you that. So again, this is my x-axis, this is my y-axis, and I had 2 points. I had 0, 3, and I also had negative 2, 0. And I know that when we were graphing, I said to do 3 points. And you can do that if you want, but I already know that this is correct, so I'm not going to waste your time by getting a 3rd point. So 0, 3 is right here. Negative 2, 0 is right here. Okay, again, this is the graph for 3x minus 2y is equal to negative 6. Now, we talked about the fact that this had a slope, m is equal to 3 halves. So I can start out at any point on this line. Remember, this is the rise over the run. Okay, so now I'm going to show you this. If I start out at this point, if I rise 3 units, so 1, 2, 3, and I run 2, 1, 2, I'm back to the line. Rise 3, 1, 2, 3, run 2, 1, 2, back to the line. Rise 3, 1, 2, 3, run 2, back to the line. It also works a different way. If I think about 3 halves as negative 3 over negative 2, negative over negative is positive, so it's the same thing. Really, I start at a point and I go down 3, so 1, 2, 3, that's my rise, and I run negative 2, so I go to the left 2, 1, 2, back to the line. Fall 3, 1, 2, 3, go to the left 2, right here. That's what slope is telling us. For every 3 units I rise, I run 2. All right, so let me show you one other thing. I want to show you how this procedure, where we have m equals, again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, works on the coordinate plane. So again, if we use the point 0, 3, and we use the point negative 2, 0, when I think about y sub 2 minus y sub 1, the y value, let's just say from here, is 3, and let's say from here it's 0. So 3 minus 0, that gives me the rise or the change in y values from here to here, right? That's my change in y, this distance here. So that's 3 units. Now my change in x values, think about 0 minus a negative 2, which is basically 0 plus 2 or 2. I'm going from here to here. So I'm traveling 2 units. And it's easy to see that the slope, again, I go 2 units to the right and 3 units up. So I rise 3, run to the right 2, or you could say you run 2 and go up 3. Either kind of way you want to think about that. We typically say rise over run, so that's why I would say increase 3, go to the right 2. And again, you can reverse that by saying negative over negative. Some instances you're going to have to do that. So you can also say that you fall 3 and go to the left 2. All right, so now that we understand kind of the concept behind this, let's just crank out a few examples. So let's say you get your homework or your test, and you're given these 2 points, and they say calculate the slope. Well, again, you're going to use the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I just generically label one point as x sub 1, y sub 1, the other is x sub 2, y sub 2. Doesn't matter which is which. So this is x sub 1, y sub 1. This is x sub 2, y sub 2. Again, I could have switched that up. It would make no difference in the calculation. So for y sub 2, I have negative 18. For y sub 1, I have 2. For x sub 2, I have 19. For x sub 1, I have negative 13. Be very careful with plugging in negatives here because you have that minus. So you want minus a negative 13. All right, so this is equal to negative 18 minus 2 is negative 20. And this is over. 19 minus a negative 13 is the same thing as 19 plus 13. 19 plus 13 is 32. So you get negative 20 over 32. Of course, we can reduce this. Each is going to be divisible by 4. Divide this by 4, you get 5. Divide this by 4, you get 8. So this equals negative 5/8. So what this means is that my slope, or m, is negative 5/8. So I would rise by negative 5 for every 8 units that I run. And when we think about negatives here, there's a couple different things we can think about. First off, remember a fraction, if the numerator is negative and the denominator is positive, I can switch that up. So when I think about slope, I can say that the rise is negative 5 and the run is 8. Or I could say the rise is positive 5 and the run is negative 8. These two are the same. When I think about a negative value for a rise, it means I'm going down, right? Vertically, I'm decreasing, going down. When I think about a negative value for a run, I'm going to the left. Just think about your number line and how you increase or decrease. If you're on a vertical number line, I increase by going up, right? Going north. I decrease by going down or going south. If I am on a horizontal number line, a typical number line, as I go to the right, I'm increasing. As I go to the left, I'm decreasing. Okay, so just relate that. All right, so let's take a look at another example. Let's say you have 15 comma negative 10 and 10 comma 6. So again, let's label these points here. And I'm going to switch it up and say this is x sub 2, y sub 2. This is x sub 1, y sub 1. And I just plug into the formula. So m, the slope, is equal to y sub 2, which is negative 10, minus y sub 1, which is 6, over x sub 2, which is 15, minus x sub 1, which is 10. Again, I'll write the formula here. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, rise over run. So negative 10 minus 6 is going to be negative 16 over 15 minus 10, which is going to give me 5. So I can't reduce that any further. My slope is just negative 16/5. So again, this tells me that I fall 16 units for every 5 that I go to the right. Or I could switch this up and say that I increase 16 units for every 5 that I go to the left. I can have 16 over negative 5 as well. All right, let's take a look at another example. So we have the ordered pair negative 7 comma negative 9 and the ordered pair negative 14 comma 12. So again, I'm just going to use my slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, copy that down and refer to it as we're working the problems. So I label each one of these arbitrarily. Doesn't matter. So I'm going to just do x sub 1, y sub 1, and this one is x sub 2, y sub 2. Again, the only thing that matters is If I put this as a 1, this is a 1. This is a 2, this is a 2. Don't mix that part up, but you can label either one as x sub 1, y sub 1, and the other as x sub 2, y sub 2. Doesn't matter. All right, so m is equal to, for y sub 2 I have 12, then minus, for y sub 1 I have negative 9, so it's minus a negative 9. Okay, be careful there. Then over, for x sub 2 I have negative 14, and then minus, for x sub 1 I have negative 7, so minus a negative 7. So 12 minus a negative 9 is the same as 12 plus 9, that's 21. Negative 14 minus a negative 7, that's basically negative 14 plus 7, so that's negative 7. So 21 over negative 7 is negative 3. Now typically with slope, we'll say negative 3 over 1, so we can still refer to rise over run. My rise is negative 3. My run is 1. So if I'm on a graph and I'm at a point there, I can fall 3 units and run to the right 1, and I'm back to the line. Or again, another thing I can do, I can switch this negative. I can say this is 3 over negative 1. So I can say the rise is 3 and the run is negative 1. So now if I'm at a point on the line, I can go up 3 and to the left 1, and I'm back on the line. All right, so pretty easy overall to find the slope of a line if you're given 2 points. If you're not given 2 points, if you're just given the equation, then you can just calculate 2 points, then plug it into that slope formula. Super, super easy to do. All right, so now let's talk about a few special case scenarios. So the slope of any horizontal line is always 0. So why is that the case? Well, we know a horizontal line just goes straight across. So its steepness would be nothing, right? It's not rising at all as it's moving to the right. So it would basically be 0 over whatever, 0 over 1, or 0 over 25. So I go 0 units up for every 1 unit I go to the right. Or I go 0 units up for every 25 units I go to the right. And this doesn't look correct. 0 over 1 equals 0 over 25. Yeah, 0 divided by any non-zero number is 0. This is 0 equals 0. Right? Have a steepness or slope of 0. So you can use the slope formula to calculate this. Remember, I can generate 2 points by choosing a value for x arbitrarily. Let's say it's 3, for example. So x is 3, y is 3. X is, let's say, 10, y is 3. No matter what I choose for x, y will always be 3. So then if I plug that into my slope formula, m is equal to, and let's say this is x sub 1, y sub 1, and this is x sub 2, y sub 2. So m is equal to y sub 2, which is 3, minus y sub 1, which is also 3. That's where you get your 0 from, over x sub 2, which is 10, minus x sub 1, which is 3. So 3 minus 3 is 0 over 10 minus 3, which is 7. 0 over 7 is obviously 0. So your vertical change, or your rise, will always be 0 because the value for y for those 2 points that you choose will always be the same. The same number involved in a subtraction problem is always going to give you 0. 5 minus 5 is 0. 20 minus 20 is 0. 2 million minus 2 million is 0. So on and so forth. So the other special scenario would be the slope of a vertical line. So the slope of a vertical line is undefined. So why do you think that is? Well, again, we go back to our slope formula. We have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If x always equals negative 4, for x sub 2 it's going to be negative 4. For x sub 1 it's going to be negative 4. Negative 4 minus a negative 4 is negative 4 plus 4. That's 0. So I'm going to have division by 0, which is not allowed. It's undefined. So that's why we say the slope of a vertical line is undefined. And again, if you want an example of that, let's say you're given a problem where you have something like negative 4 comma 3, and let's say you have negative 4 comma 2. If you see the same value for each x, you know you have an undefined slope. Let's say this is x sub 1, y sub 1, and this is x sub 2, y sub 2. Just try plugging it in. So for y sub 2, you get 2. For y sub 1, you get 3. For x sub 2, you get negative 4. And for x sub 1, you also get negative 4. And remember, minus a negative is plus a positive, so really this is negative 4 plus 4. So 2 minus 3 is negative 1, but it's over 0, so again, this is undefined. All right, so a couple of just key points on slope. So a positively sloped line rises as we move to the right. So if you see a slope that's something like 3/5, I know this is positive. I know that as x increases, so as we move to the right, that line's going up. So a positively sloped line looks something like this. Again, as we're moving to the right, as x is increasing, the values for y are increasing, so I'm going up. Then similarly, a negatively sloped line falls as we move to the right. So as x increases, in this case, a negatively sloped line would have a y that decreases. So you'd see something with a negative slope. You have a negative, let's say it was negative 3, or let's say negative 2/5, or something like that. That type of line, again, falls as it moves to the right. So it looks something like this. As we move to the right, as x increases, the y values are decreasing. All right, so now let's get into something that is going to probably piss you off. Slope can be found without using the slope formula. It can be found directly from the equation of a line. So I know a lot of students, they get these equations, they go through, they figure out these points, and they plug in the slope formula. They do all this work, and then they figure out that it's so easy to just solve for y. Often they get really, really mad. So hopefully you're not upset about that. It's important to understand all the techniques that we have in math, because sometimes you're not given the equation. Sometimes you have to generate it. I have here that y equals mx plus b. You remember that m stands for slope. So if I just solve the equation for y, the coefficient of x is the slope. And I'll prove that to you in a second. B is something that's new for us, not if we took Algebra 1, but if we haven't seen this before, B is basically the y coordinate for the y-intercept. So in other words, if I plugged in a 0 for x, m times 0 would be 0, so this would disappear. I'd have y equals b. So the coordinate 0, comma b is your y-intercept. All right, so let's say we're given an equation x minus y equals 28. And I tell you to find the slope. So all I'm going to do is just solve it for y. So I want to isolate y on one side. So the first thing I'm going to do is subtract x away from each side. So I'll have negative y is equal to negative x plus 28. Then I just want to get rid of the negative. So let's divide both sides by negative 1. And so this will cancel with this. I'll have y is equal to, you think about this as dividing each by negative 1. So negative x is divided by negative 1, so that's x. And then 28 is divided by negative 1, that's minus 28. So y equals x minus 28. So the coefficient of x here is understood to be 1. So that's my slope. And my y-intercept would occur where? Well, if I plugged in a 0 for x, I'd have negative 28 as my result for y. So my y-intercept is at 0, comma, negative 28. Again, this is m, this is b. And when you think about b, you want to think about the sign that's in front. I could really write this as plus negative 28 if I wanted to, so that's why we write 0, comma, negative 28. All right, so let me prove to you that this works. I'm going to prove to you that the slope is 1 here. So let's say you didn't know what I just taught you, and you're given this and your only technique is to use the slope formula. So you generate 2 points. Let's say that you generate, I don't know, let's say x is 12. What would y be? So plug in a 12 there. So then I'd have 12 minus y equals 28. I would subtract 12 away from each side of the equation. That cancels. I have negative y is equal to 28 minus 12 is 16. Divide both sides by negative 1. You get y is equal to negative 16. So if x is 12, you get y is equal to negative 16. As another point, let's just say we pick, I don't know, how about 14? So if x is 14, what's y? So 14 minus y equals 28. We would subtract 14 away from each side of the equation. That cancels. You get negative y equals 14. Multiply both sides by negative 1, or divide by negative 1, whatever you want to do. You'll get y equals negative 14. All right, so now let's plug into the slope formula. So the slope formula, again, we have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's just say this is x sub 1, y sub 1, and this is x sub 2, y sub 2. So then my y sub 2 is negative 14. My y sub 1 is negative 16. My x sub 2 is 14. My x sub 1 is 12. So negative 14 minus a negative 16 is the same thing as negative 14 plus 16. So negative 14 plus 16 is going to give me 2. 14 minus 12 is also 2. 2 over 2 is 1. So you remember when we solved this equation for y, we found that the slope was 1. So look how much easier that was. This took us forever. We had to generate points. We had to plug it into the slope formula, so on and so forth. So solving an equation for y is generally going to be the quickest way to find the slope. All right, let's look at one more of these. So suppose you get 6x minus y equals negative 8. Again, you want to find the slope. Isolate y on one side. The slope is given as the coefficient of x. So let me subtract 6x away from each side of the equation. That'll cancel. You'll have negative y is equal to negative 6x minus 8. We would then just divide both sides by negative 1. So I'd have y is equal to negative 6x divided by negative 1 is 6x. Negative 8 divided by negative 1 is plus 8. So then I have y equals 6x plus 8. So the coefficient of x, which is 6, is my slope. This is m. All right, remember, y equals mx plus b. My y-intercept occurs at 0, 8. Again, plug in a 0 for x. 6 times 0 would be 0. I'd have y equals 8. So this is my y-intercept. And just one more time, let me prove to you that this works. So I'm going to write here that m equals 6. And I'll verify this for you. Let's just say that x was 0. So 6 times 0 minus y equals negative 8. So this is 0 minus y equals negative 8. Divide both sides by negative 1. And I'll have y is equal to 8. So if x is 0, y is 8. That's 1 point for us. As another point, let's say x was negative 2. So negative 2 comma what? So 6 times negative 2 is negative 12. Then minus y equals negative 8. Let's add 12 to both sides of the equation. That'll cancel. I'll have negative y is equal to negative 8 plus 12 is going to give me 4. Divide both sides by negative 1. And you get y is equal to negative 4. So again, let's use our slope formula now. And we'll label each point arbitrarily. Let's say this is x sub 1, y sub 1. This is x sub 2, y sub 2. So I use my formula. M equals y sub 2, which is negative 4, minus y sub 1, which is 8, over x sub 2, which is negative 2, minus x sub 1, which is 0. So negative 4 minus 8 is negative 12, over negative 2 minus 0, which is just negative 2. And if I divide negative 12 by negative 2, negative over negative is positive. 12 divided by 2 is 6. So I get m equals 6 in the end, which is what I found pretty quickly by just solving the equation for y. So kind of some wrap-up notes here. Finding slope is not very difficult at all. You can use the slope formula if you know 2 points on the line. So if you're given an equation and you want to use the slope formula, generate 2 points for the line and plug them into the slope formula. Otherwise, if you want to find the slope, you can solve the equation for y. The slope is given by the coefficient of x.